Okay, in this video we're going to look at higher order derivatives. So differentiating f of x, which is a function of f of x, a function of x, gives us df dx. We've already seen this before. Now, actually, df dx is the first order derivative. First order derivatives. There are other derivatives which are going to be of higher order. So then if we differentiate df dx, then we are going to get a second order derivative. Differentiate df dx. So this is going to give us the following situation. So differentiating anything with respect to x means working on it with the operator d dx. So here we are differentiating df dx. So this is the same operator that we used here. So if we start with this, then we do dx, then we get that. So if we're differentiating df dx, then we operate on it with d dx. Now so simply multiplying here means that in the numerator we're going to have d squared. So indeed we write d squared f in the numerator. In the denominator we're going to have dx squared. Okay, however, for brevity, the denominator we write without the brackets. Okay, so we just write d squared f dx squared, and so this is our second order derivative. Now using the prime notation, so this is just going to be f prime. Remember, df dx is f prime, so I beg yours, this one is going to be f double prime. I'm going to set out a table here for the other derivatives. So on the one column we're going to have the order, and then on this column we're going to show the notation for that derivative. So already we've seen that for second order we have got dx d squared f dx squared. This is the same as f double prime. And then for order 3, this is going to be d cubed f dx squared f triple prime. For order 4, we're going to have d to the power 4 f, and then dx to the power 4. Now for derivatives of order beyond 3, then we don't continue with the prime notation. We then use the Roman numerals. Either we use the Roman numerals, or if we stick with the Arabic numerals, then we use brackets there. So this is the fourth derivative of f, while this is f to the power of 4. All right, so that is in terms of notation of higher order derivatives. Now let's have a look at a few examples of how we work out higher order derivatives. All right, in these examples, we're going to be finding the indicated derivatives. So in the first two, we're finding the fourth order derivative. In the last two, we're finding the second order derivative. So let's get going. So these just involve really differentiating repeatedly until we get to the order of differentiation required. Here we're going to differentiate 4 times. So these are powers of x, so straightforward really. We multiply for the first one by 5, we subtract 1, and then again for the next one, 3 times 4 is going to be 12, we subtract 1, so that is the first order derivative. And then differentiating that 1 in 10 is going to give us the second order derivative. So 5 times 4 is going to be 20, we subtract 1, power is now going to be 3. 2 times 12 is 24, we subtract 1, so it's going to be 24x. Okay, then 2 more to go. 20 times 3 is going to be 60 this time. The new power is 2. Derivative of 24x is just going to be 24. And then the required derivative, which is the fourth order derivative, 2 times 60 is going to be 120. So x, the fourth order derivative of the given function, is going to be 120 x. Okay, so let's go to example number B. In B, we have got x to the power of 4 plus 2 over x squared. Again, we're looking for the fourth order derivative. The first thing we're going to do this time is we're going to have to rewrite this one so that the x is in the numerator. So it's going to be x to the power 4 plus 2x to the power minus 2. Notice, as we've mentioned before, even though this looks like a quotient, we don't have to use the quotient rule because there is no x in the numerator. So now, straight away, first derivative, we multiply by 4, we subtract 1, and then the second derivative, we multiply by 2, negative 2, we subtract 1. So this is going to work out to 4x cubed minus 4x to the power minus 3. And then we differentiate again. So second order derivative, 4 times 3 is going to be 12. We subtract 1, and then that's going to be minus 4 times minus 3. We subtract 1, that is going to be minus 4 now. So this simplifies to 12x squared plus 12x to the power minus 4. Differentiate again, the third order derivative, 2 times 12 is 24, we subtract 1, and then this is going to be 12 times 4. So 12 times negative 4, there we subtract 1. So this is going to be 24x minus 12 times 4 is 48. So, and then x to the power minus 5. And then the fourth order derivative, derivative of 24, x is going to be 24, and then minus 48 times negative 5. The new power is now going to be 6. So 48 times 5, this is going to be plus now. 5 times 8 is 40. 5 times 4 is 20. So that's going to be 240 x to the power 6. And so that's going to be our fourth order derivative. All right, now we're going to go to example number C. In example number C, we have got y equal x times the square root of 1 minus 2x. We are looking here for the second order derivative. So what's going to happen here is we're going to have to use the product rule, because the expression is a product, this term times this other term. So we're going to use the product rule. So we're going to let u be equal to x. Then the derivative of u is going to be 1. We're going to have to let v be square root 1 minus 2x. We're going to have to use the chain rule to find the derivative of v. So if we first differentiate the power, that means multiply by a half, subtract 1. Then after that, we're going to multiply by the derivative of the inner function. So that's going to give us negative 2. Negative 2 times a half, it's going to be negative 1. And then I'm going to write this as a square root in the denominator. Okay, so from this, it means by the product rule, y prime is going to be u prime v plus u v prime. U prime is 1. Okay, and v is just that square root there. So we're going to have 1 times square root of 1 minus 2x. And then plus u v prime. U is x, v prime is negative 1 over square root of that. We are yet to differentiate this again. It's going to be helpful then to write it as one fraction. Otherwise, we are going to have to be differentiating too many terms. So if you write this as one fraction, we're going to say this over 1, then the LCM is just this one there. So square root 1 minus 2x. 1 goes here this many times. So then this times this is just going to be 1 minus 2x. Then notice is a minus here. Then this goes into this once, but so it's going to be 1 times x. So this thing is going to work out to, so in the numerator we're just going to have 1 minus 3x. In the denominator we're going to have that. Okay, so that means we're going to have to now use the quotient rule for the second order derivative. So in the quotient rule, we're going to let u be 1 minus 3x. So u prime is going to be minus 3. We're going to let v be square root 1 minus 2x v prime. Now notice that fortunately we have already done the derivative of square root 1 minus 2. It's sitting right there. So that is going to be that. So we don't have to recalculate it. Okay, and then we can simply plug these into the formula for the quotient rule. So the second order derivative is going to be uv minus uv all over v squared. So remember we said if you having trouble memorizing this, then you just remember that these are in alphabetical order, and then even the way we do the derivatives, we start with the u, so it's u prime v minus u v prime. So this time u prime is -3, v is that square root 1 minus 2x, take away u is 1 minus 3x, v prime is -1 over square root 1 minus 2x, all divided by v squared is just going to be 1 minus 2x. And then to simplify this, what we're going to have to do is to write this as one fraction. Okay, so I'm going to do that just here. So again, we write this over 1 and then do the LCM. So just notice here, minus and minus is going to give us plus there. Or maybe I am not going to do it separately. Let's just do it as part of that main expression. So we're going to have, so this is our numerator here, and it's got its numerator is that square root, and then again 1 goes here, square root 1 minus 2x times, so we multiply this times this, we're going to get -3 into 1 minus 2x. This sign is now plus this one here because of the minus there. This goes here once, so that's just going to be 1 minus 3x. And then if you remember your fractions well, this is going to come into the denominator. So then in the numerator we have got -3 plus 6x plus 1 minus 3x. In the denominator I've got 1 minus 2x to the power 3/2. Then the numerator simplifies to 6x minus 3x is 3x. Then that is going to be -2, and then all divided by 1 minus 2x all to the power 3/2. So that is going to be the second order derivative of that one. In D, we have y is equals to 2x squared plus 3 all over x squared minus 2. Again, we're looking for the second order derivative here. This one is a quotient, so we're going to use the quotient rule straight away. So let u be equal to 2x squared plus 3, so u prime is going to be 4x. Let v be equal to x squared minus 2, v prime is going to be 2x. So y prime is going to be u prime v minus uv prime all over v squared. This is going to work out to u prime is 4x, v is x squared minus 2, v prime is 2x. I'm going to write it first. U is 2x squared plus 3. So this is all divided by x squared minus 2 all squared. Removing the brackets is going to give us 4x cubed minus 8x, then minus 4x cubed minus 6x all over x squared minus 2 all squared. The x cubed terms are going to cancel out, and so we're just going to have minus 8x minus 6x, so it's going to be negative 14x all divided by that. Okay, so that is our first order derivative. Then for the second order derivative, again we're going to have to use the quotient rule. So this time if u is negative 14x u prime, it's just negative 14. V is the x squared minus 2 all squared. So for v prime, we're going to have to use the chain rule. So multiply this by 2. We subtract 1 and then multiply by the derivative of the inner function. So this is going to be 4x into x squared minus 2. So what it means is that our second order derivative is going to be u prime v minus uv prime all over v squared. U prime is negative 14. V is x squared minus 2 all squared. Then take away u v prime. There is v prime. There is u. So that's going to be negative 14x times 4x x squared minus 2 all divided by x squared minus 2 to the power 4 this time. Okay, now before we work through this, simplify this, we notice that this term is common right through. So we're going to factorize it in the numerator. So if we factorize x squared minus 2 to the power 1, then the numerator is going to be negative 14 times x squared minus 2. This second term is going to be plus because of the two negatives there. 14 times 4 is going to be, so 4 times 4 is 16. Then 4 times 1, so it's going to be 56x. And that's just going to be that because x squared minus 2 is already been factorized. Then this is divided by x squared minus 2 all to the power 4. So what's going to happen is this is going to cancel out with one of those. Now we are getting towards the final answer. So what's going to happen is that the numerator is just going to be, so negative 14 times negative 2 is positive 28. Then we're going to have 56x minus 14x squared. This is all going to be divided by x squared minus 2 to the power 3. So that is going to be our second order derivative. Okay, what we're going to do now is we're going to give you the opportunity to have a go at a few exercises. You're going to start with E. So in E we have got 32 times square root x minus 5x squared. You're going to want to find the fourth order derivative. In F we have got the square root of x squared plus 1 you're going to find the third order derivative, and in G we have got x over square root 2x minus 1. You are going to find the second order derivative. Right, so if you just want to pause the video, have a go at these, and then when you continue the video you can compare with our answers. All right, we're now going to scroll down to our answers. So for E, we have got 32 square root x minus 5x squared. We're looking for the fourth order derivative. The first thing we're going to do here is to write square root x as x to the power half, and then these are just powers, so we're going to use the power rule, multiply by the power, subtract 1. So for 32x to the power half, we multiply by 1/2 and subtract 1. The new power is going to be minus half. Here 2 times 5 is going to be 10, so this simplifies to 16x to the power minus half minus 10. Then for the second order derivative, we do the same thing, multiply by the power, subtract 1. Here we get 10, simplifies to negative 8x to the minus 3/2 minus 10. Multiply by the power and subtract 1. For the third order derivative of a constant is 0, so that disappears, and this simplifies to 12x to the power minus 5/2. Multiply by the power again and subtract 1, simplifies to negative 30x to the power minus 7 on 2. In G, we've got the square root of x squared plus 1. We'll write it as a power. Then we're going to use the chain rule. So for first order derivative, first we differentiate the power and subtract 1, keeping this exactly as it is. And then once the power has been differentiated, then we're going to multiply by the derivative of the inner function, which is going to be 2x. Then 2x times 1/2 is x, and then we write that in the denominator. Now, so that means for the second order derivative, we're now going to use the quotient rule here. So we're going to let the numerator be u and the denominator be v. When v prime becomes 1, u prime becomes 1, the v, this is exactly the same as what we studied with here. So we've already seen to differentiate this, we get that. So we can simply copy that and put it here. So that's going to be v prime. So we plug this into the quotient rule. So u prime is 1, and so multiply that by v, and then minus uv. U is x and v is that term. And then again, what we need to do whenever we've got this type of situation, we need to write this as a single fraction. So that over 1. So the LCM is just going to be this term here, and then 1 goes square root x squared plus 1 times. Multiply this by that, we get that. This, on the other hand, goes once there, so we're just going to have that x squared there, and this is just this term, it just tucks in to the denominator. Okay, and then the numerator just simplifies to 1. So now, since there is no x in the numerator, unlike what was the case there, it means if we have to differentiate this again, we don't need to use the quotient rule because there is no x there. So we just write it like this and use the chain rule, and that's going to be much quicker and more efficient than if we had used the quotient rule. So simply multiply by the power here. So multiply by minus 3/2, subtract 1, keep this fixed, then multiply by the derivative of that. Then 2x times minus 3 halves is minus 3x, and then we bring that in the denominator, and that is going to be our final expression. In G, we have got a quotient, so we use the quotient rule. U is x, U prime is going to be 1. Then V is equal to 2x minus 1. So we're going to use the chain rule here. Multiply by a half, subtract 1, and then multiply by the derivative of the inner function. So that's going to look like this. Then we plug this into the chain rule, we get this thing, and then again we have got this same or a similar situation to what we had there. So again, we're going to write that as a single fraction. The LCM is this one, and when we work this out, the numerator works out to x minus 1, and the denominator works out to that. We still have to differentiate this again, so remember that's just y prime. So since it looks like this and there's x there, then we're going to use the quotient rule, of course. So u is x minus 1, u prime is 1, and v is going to be 2x minus 1 to the power 3 halves. We differentiate this, we get 3 into 2x minus 1 to the power 1 half. And then we plug it into the quotient rule. And then when we've done that, we notice that again, there is a common factor of 2x minus 1 to the power half. So the common factor is always the smaller power of the two. Just scroll up. We have met a similar situation here. So here we're at power 2 and power 1. So we factored out the x squared minus 2 to the power 1. So this time the smaller power is power of 1 half. So we factorize that, and then the remaining function is going to look like that inside the square brackets. Then we divide this into that. So that's going to be 2.5, which is the same as 5 halves. And then if we simplify the terms inside the square brackets there, simplify is 2 minus x, and that is our denominator. All right, there is a number 2 to these examples, which we're going to do in part 2 of this video. Otherwise, thank you for watching now. Hopefully this was useful. Please do subscribe and like the video, and comment in the comment section, and share this with friends who you may know need this type of material. Thank you.